All right, y'all. In this video, we're going to try to wrap up what we have on hyperbolas. So if you missed the first video where we went through the notes for that and the first example, then make sure that you go back and view that. And then in this one, we're going to cover the rest of the examples. Fingers crossed, right? I've got 4 more, I think, for us today. So here we have example 2, and it says that we're going to find an equation of the hyperbola with foci at 0 plus or minus 3 and a conjugate axis length of 4. And we want to find the asymptotes and sketch it. So that's kind of a tall order. We got a lot going on. The first thing I'm going to do is I'm going to get the equation of it. I can kind of start the sketch to help me get the equation if you are a very visual person. So since they are asking us to sketch it anyways, you could use a little bit of a sketch to kind of help out with that. The first thing that I'm really noticing is them giving us the foci right there, which is really nice to work with. Because we can usually see like our C value from that. Sometimes we can tell the center if it's 0, 0, or we can tell parts of our center, even if it wasn't. And so we can kind of tell, a lot of times we can even tell which way this thing is going to be facing. So for some of y'all looking at this, the focus points here, 0 and then plus or minus 3, if you were to just look at your foldable that we got in our notes, a lot of you guys would immediately jump to this and say, yeah, there's 0 plus or minus C. And that does work to help you see what's going on. The 3 from my problem is going to be the C value. This fits that exactly. So it makes it really easy to view, but not everybody is going to be great at looking at the equations. And if you don't have the equations in front of you, what do you do, right? So if they're in front of us, that's nice. We can see vertical axis, center 0, 0, all of that jazz. But what if you don't have them with you? Well, that's where sketching might come in handy the most. So I want you to think about like where those points are. 0 minus 3 is going to be down here. And then we're going to have 0 plus 3 would be up in here, right? So just seeing that, these are our foci. And again, we can use this sketch as part of my actual sketch at the end. So, that it doesn't hurt to go ahead and do this either. If you see it like this, then there's lots of information that you can get from that. The C value, like we were saying before, that C value from the center to the focus is going to be 3. I can tell that halfway between these focus points is going to be the center of 0, 0. And we can tell that this is going to open up and down because those focus points go inside of the little U-shape part of the hyperbola. So there's a lot that we can tell from this. So I'm just going to kind of write out a little bit of it. Center is going to be at 0, 0. We're going to open up and down. I'm going to say C was 3. We can definitely get that. And yeah, let's see what else we can do. They told me the conjugate axis length is 4. Now I want you to remember what conjugate axis was, right? Conjugate axis is this one here, the 2b. So if they tell me that the conjugate axis is 2b, then I can say 2b equals 4. And that, again, just comes from the conjugate axis part. That means b is 2. Awesome. Now, if I'm supposed to be figuring out the equation, I need b and a. I've got b, but in order to get a, we're going to have to do a little bit more work. So let's do that. We have a lovely little equation here. The c squared equals a squared plus b squared. We can use that to figure out what the a is going to be since we don't have it. And so I'm going to say c squared equals a squared plus b squared. And we're just going to plug in stuff. So if c is 3 and then b was 2, go through and solve this out. Subtract that 4, we get 5 equals a squared. Square root that. Again, when you square root both sides, a lot of times we say plus or minus. Since a is indicating a length, we can just leave it with the positive, and that's okay. All right, now as far as putting those values on the graph, it's actually going to be easier for us to put it on the graph if we see it as a decimal. So that just as a decimal, it's going to be like 2.2 or something like that, give or take. So anyways, that's where we're going to be kind of eyeballing those vertices. If you remember, that a value talks about the distance from the center to a vertex. And so I'm looking at these values being at 1, 2, and some change. So that's where that's going to be. It's hard to tell where I put that. That's a vertex right here. And then up here, 1, 2, and some change. Okay, we'll add to that in a minute, but that kind of gives me a little bit more to put on my graph. I do have A, I have B, and I know the center is 0, 0, so we should be able to give the equation. And so our equations are going to be, go back to your little formula. Remember how we said centered at 0, 0, and it's opening up and down. So we're going to do this equation where the y squared over a squared is first. Oh, sorry, I was putting y equals as if I was going to do the asymptote part. That's where my brain was for a second. All right, so we're going to start out here with y squared over the a squared. A squared, if you recall back here, was 5 minus x squared over b squared. 2 squared is 4 equals 1. So here we have a lovely little equation. We also were asked for the asymptotes, so I'm going to just follow the pattern for the equation of the asymptotes down here. We'll include those on our sketch as well, just to make sure we've got all our bases covered. So now we have y equals, and plus or minus a over b, so root 5 over 2x. Those are your asymptotes. All right, and like I said, we'll include those on the sketch here in just a second. Okay, so when I graph this thing, I'm just going to add to the sketch we had going. I've got my foci, I've got my vertices kind of in this pinky color, maybe hard to see. And then we need to figure out how kind of wide is the parabola going to go. And the easiest way to do that is to show where those asymptotes are, and then you make your parabola or your hyperbola approach it. So if this is the slope of my line, okay, keep in mind that this is, think back to your algebra 1, guys, this line is going to go through the origin, and it's going to have a slope of root 5 over 2. So that's about 2.2 up for every 2 it goes over. We have 2 lines, one that's positive slope and one that's negative slope. So we'll see them crisscrossing, going diagonal. So I'm looking at going about 2.2 and then over 2. Over 2, something like there. It's going to go through that origin, 2.2 over 2, something like there. And so here's where a little asymptote would be. Just kind of draw those with those little dashed lines. You don't want it to be real dark. Then we're going to have another one on this side. That's the exact same situation, except going downhill. And you're going to see these crisscross like that. The benefit of drawing those asymptotes in is, again, we can kind of see how our hyperbola is going. We can kind of see that it is going to go from those vertices and then kind of follow like that. So it's going to kind of approach those asymptotes, but not ever hit them. Something like that. Okay. There's the sketch. We got our equation, got our asymptotes. Check. Everything's done. All right, next one. Oh, my pen bled. Okay, example 3. It said find the standard form of the equation for the hyperbola whose transverse axis this time. And the transverse axis has endpoints -2 and -2, -1, and 8, -1, and whose conjugate axis length is 8. So I'm seeing there I should be able to get the A and the B value not pretty nicely because they're giving me information about my transverse axis, which will help me with A, and the conjugate axis, which will help me with B. And I should be able to see halfway between these points should be where my center is. Okay, so we can get the equation of that hyperbola if I know the center. If it's at 0, 0, awesome. But if not, I need H and K, right? And then we need our A and our B. So I think we should be able to get all that pretty easily. It can help to draw a picture. I know it didn't say to sketch it, but if you see that this has a point at -2, -1, and then at 1, 2, 3, 4, 5, 6, 7, 8, -1, okay, then this is definitely not centered around the origin because we want to look at halfway between these two. Now, people do this a multitude of ways. Some people find, like what I did back in our lesson video for 6.4, we had one where we had points like this, and I just used distance formula to find the distance between the two, and that was the length of that axis. And you can totally do that. But a lot of people will just do this by visually eyeballing those points and then just finding halfway. Some people will say from -2 to 8, that's a distance of 10, just like they can see that. And so a lot of people do all kinds of different things here. If you recognize that the whole length of this from -2 to 8 is 2, that would mean that 2A is 10. So you need to make sure you're not thinking that's A. That's 2A, okay, which would make A be 5. So that would be important. Again, your center is going to be halfway between the two. So if the whole thing is 10, so halfway would get you to the center, and you can count 5 points over. Your center should be right here at 3, -1. So like I say, there's a multitude of ways that people get this stuff, but that would be the H, and that's the K. So when I give my equation, I'll need those values. The other thing that we would need is B, and then we should just be able to write the equation for this. So B is going to come from that conjugate axis, which is going to be 2B equals 8, which means B is 4. So when I give my equation here, we need to recognize that this is where the center is at HK. We want to use that set of equations. We're going to plug it into that. We also need to see which way is this opening. And you should be able to tell based off of your kind of sketch here even. You can tell that this is going to have to open like going this way and this way. Like that's the way that hyperbola is going to have to go if that's where the endpoints. No, it should be going through those points. Sorry, I was thinking like it was like the last one where those were the focus points. No, those are the actual vertices. But yeah, so that's going to open sideways, right? So when I look at my stuff and I'm trying to decide what am I going to, like what structure am I using? It's this one where it's left and right. So that X is over that A squared term. It's that leading piece, okay? So we'll have our equation is going to be X minus H, so minus 3 squared over A squared, which was 25, minus Y minus K, so minus a negative makes plus squared, and then we have over B squared. B squared is 16 equals 1. Ta-da! Okay. We did it. Couple more examples, y'all, and then we will be done with this section. So we've got example 4 right here. And so it says find the center in the foci of the hyperbola. I've heard people pronounce this word a multitude of ways. I've heard people say foci, I've heard foci, and I've had professors call it all kinds of different things. So I've never actually looked at the pronunciation. I could be saying it a little bit funky. I don't know. But anyways, as long as we know what to do with it, that's what's important, right? They said find center, vertices, and the foci of the hyperbola. All right, I want you to notice here, remember I told you guys in the last video, A doesn't have to be more than B. So if you look here, that A term is going to be from this first fraction, right? Because that's the positive fraction. And the B term comes from the negative fraction. So you got to rewire your brain a little bit with hyperbolas. It is not the largest denominator. Okay, find center, vertices, foci of the hyperbola. We need to know A, B, C. A, B, C. We need to know H and K. So we're going to have to go on a journey to find all of those, and then we'll be able to give all those answers. So I'm just going to go through and find the little values first, and then I'll give the answers at the end altogether. All right, first thing I'm looking at the center. I guess we could go ahead and list that one because that's my go-to is I want to say what the center was because it's the first and easy thing to get and we'll need it. So -2, +5. I'll just put my answers over here. Okay. And then we need to figure out A, B, and C so that we can get the foci. Okay, so we're going to do A squared equals 9. A is going to be 3 then. That'll help me with the vertices. B squared equals 49, which means B is 7. Cool. And then so I need to get C then. And then we'll find those other pieces. So C is going to be that C squared equals A squared plus B squared. So 9 plus 49. C squared is 58. And that means C is the square root of 58. I'll just leave it like that. Okay, so to give my vertices, okay, vertices are going to be a little bit interesting. We've got to figure out which way are we opening. We know our center is not at the origin. So I see that X is over the A value, right? And so if X is over the A value, it's opening left and right. It's going to follow that pattern. So for me to get my foci and my vertices, I'm going to use these little patterns here, where it's going to be H plus or minus C, K for the foci, and then H plus or minus A, K for the vertices. So that's what I'm going to follow. Looking at H plus or minus A for this one, and then K. Well, we know the center, HK, that's -2, 5. So that's going to be -2. And we want plus or minus A, so plus or minus 3. And then our K value, 5. Some people are good with you leaving it like this. I do want us to separate this into two different solid points instead of having the plus or minus because these are rational numbers and we should be able to do that fine. So our points here, I'm going to look at -2 minus 3 is -5, 5. And then we also have -2 plus 3, and that's going to be 1, 5. Okay, so we had our center, we have our vertices. Last thing we need to get is the focus points. So foci. That one's H plus or minus C. Okay. Now C here is irrational, so I am okay with you leaving it in that square root format. So again, H was -2 plus or minus root 58, 5. And since that's irrational, I'm going to say just leave it. All right, we found center, vertices, foci. We're done. One more problem, y'all, and this is our favorite, completing the square type of situation. It says write the hyperbola in standard form. And you can tell from this that that's going to be a little bit of a tall order because we have so many different terms. We've got x squared and x and y squared and y. So having all those pieces always makes it a little bit more of a challenge. So it's not just like it was on example 1 from our last video. We do need to use our completing the square. Once we know the standard form, we should be able to get the vertices and the foci. So let's just go on a little journey here. Okay, first things first, I'm going to rearrange this so that I see my x's together, my y's together. Now, here's how I decide what to put first from the beginning. Do you see how the y squared term is positive, but the x squared term is negative? That's a really strong indicator that we should be writing this as with the y squared term first and then minus x squared, because that'll fit our standard form a little bit closer. So here we have 25y squareds minus 50y. Then we're going to say minus 9x squared minus 54x, and then add that 281 to the other side. All right, and the next thing I'm going to do is I'm going to take out the leading coefficient for our squared terms. So here I'm going to take out 25. So I have y squared minus 2y. Here's where you have to be the most careful with the hyperbolas and how you have to just something a little bit extra than what we had in the ellipses. You see how this is a -9? So when I factor this out, I'm factoring out a negative with it. So this is x squared plus, right, because I factor that negative out. So plus 6x. And then here we go, 281 on the other side. Okay. All right, next thing, we are going to complete the actual square here. So we're going to do the trick where we take half of our linear term, square it, and add it to both sides. So half of 2 is 1. 1 squared is 1. So we're going to add 1 inside those parentheses. What I want you to remember is this value is not actually 1. This value is 25 times 1. So what we're adding is 25 times 1, right? Which is actually going to be 25. For the other one, and again, this you have to be a little bit more careful with the ellipses. That's the only like negative to it, is we do have to be a little bit more, just a little bit more careful. Slow down just a little, okay? So with our x's here, we're going to take half of this, which is 3, square that, which is 9, and we're adding 9. But remember that this is 9 times -9. So truly, this had subtracted 9 times 9. Or you can look at it as saying plus 9 times a -9. Okay? But you got to keep in mind that that negative does affect it as well. Okay? It makes that actually a negative value. So in my next line, let's go ahead and combine things. This is going to give us 25. I tend to make shortcuts when I do my own work, but I'm trying not to. So we have y squared minus 2y plus 1 minus 9x squared plus 6x plus 9. Over here, we can write it all the way out if you wish, or you could just combine it at once. It kind of depends on you. Okay. All right, now here's where I'm going to do my completing the square. Like we did the completing the square, now we have to factor that. They are perfect square trinomials. That was the whole point. So to be able to factor these, I'm looking at things that multiply to be 1, but add to be a -2. And that's -1 and -1. I can just write it once with a squared on it. Here with my x's, things that multiply to be 9, but add to be 6. That's +3 and +3. And then over here, when we combine all this together, we should get 225. It's not too bad to add. Okay. Next thing, still not quite in standard form. We're getting close. We just need to divide through by the 225 so that I have it equal to 1 on this side. So we're going to divide 225 That's going to simplify, leave me with a 9 down here. Simplify, leave me with a 25 down there. That's kind of trading places, huh? That'll leave me with a 1 on that side. So when I simplify this and write it out nicely, the equation, writing this in standard form, we're looking at y minus 1 squared over 9 minus x plus 3 squared over 25 equals 1. Ta-da! That should give us that equation. From there, we can find the other pieces where they want the vertices, they want the foci, right? We want all those parts. So let's find our A and our C, right? And in order to get the C, we'll probably have to get B as well. So let me find those little pieces here. All right, A squared equals 9. That's going to come from that first piece there. A equals 3. All right, B squared is equal to 25. So see here, A was actually less than B. B is going to be 5, right? All right, then we have that idea with the C squared. I'm just going to write it underneath here, actually. C squared equals A squared plus B squared. So C squared equals 9 plus 25, which is 34. Square root it. That's about as nice as that can get. So we're going to leave it like that. And to give our vertices, right, I'm just going to list my final answers right there. So I'll do the work over here. But keep in mind, we are opening up and down because y was first. And my center is not at the origin. My center is at 1, -3. That's h, that's k. Right? So use that. So we're going to follow these patterns where we're opening up and down. Center was not at the origin. And that's the h and then k plus or minus c, or k plus or minus a. That's what we're following. So for my vertices, we're going to say h and then k plus or minus a. Okay. Well, that's going to be 1 and then -3 plus or minus 3. Oh, pause. My center. I didn't catch this. 1 sec. I was thinking something seemed a little bit off. Okay. I grabbed H and K, but I wasn't looking at the actual order. H has to be with 3, and then, or has to be with that X, and K has to be with Y. So I have these swapped. My bad. I'm going to fix it. So these will swap. My bad, guys. I haven't had my coffee yet, so I'm going to blame it on. Okay, so my H value is -3. My K value is 1. So -3, and then there we go. That feels better. Okay, something fell off. All right, here we go. -3, and then 1 minus 3 is going to give you -2. Then -3, and then 1 plus 3, 4. And that gives us our two vertices. -3, -2, and -3, 4. All right, my foci, let's get those real quick. That's going to be H and then K plus or minus C. That shouldn't be too bad because C was actually irrational. So, and that's fine to leave it in this weird format. So -3 and then 1 plus or minus root 34 should be all we need to do. I can't really simplify that. So -3, 1 plus or minus the square root 34. Okay. We got everything. I'm not sure that we'll be able to fit this into one class period when we do this in class. We may end up having to save this one example for another day. We will see how that goes. It kind of depends on the class period maybe. But anyways, that is the rest of it for this section at the very least. So if at any point you've missed an example, we should have that now. All right, guys, that is it. We have completed hyperbolas. You need to make sure that you work on the assignment to get that turned in, and I will see you guys later. All right, bye.